Hi everyone, this is Kiranmai from H&S department. Today we are going to discuss about one of the electronic device which is a semiconductor diode, that is an avalanche photodiode. Here in this topic we are going to discuss about key points of the avalanche photodiode, construction, working, merits and demerits of avalanche diode and applications of this. Coming to the avalanche photodiode, it is a highly sensitive semiconductor photodiode that exploits the photoelectric effect to convert light into electricity. An avalanche diode is one of the kind of semiconductor device specially designed to work in the reverse breakdown voltages. This is as similar as an GNR diode only, because GNR diode is also a semiconductor diode which works perfectly in a reverse biasing conditions. The avalanche diode comprises of two terminals, namely anode and cathode. Coming to the construction of avalanche diode is made from silicon or other semiconductor materials, uh, which is as similar as a GNR diode. The construction of avalanche diode is also similar to GNR diode, except the doping levels in this diode changes from GNR diode. Whereas in GNR diode, the doping levels are very high than a PN junction diode. On the other hand, avalanche diodes are doped lightly. So the depletion layer width of avalanche diode is very large, evaluated to GNR diode, due to which there will be a more chance that more electron hole pairs will be created when light energy falls on this region. So because of the large depletion region, reverse breakdown takes place at very high voltages in the diode. As on the screen, you can observe that there is a p-type and n-type layers with a very high junction barrier between them. When this region is illuminated with the photons of certain energy, those photons will knock out the electrons from the ions which are present in the depletion region. Hence, electron hole pairs will be created. Those electron hole pairs will move away from the junction towards the p-type and n-type materials with a very high velocities. The main difference of the avalanche photodiode to the other forms of photodiode is to operating it in high reverse bias conditions. Since all the other photodiodes can be operated in the forward bias conditions also, but this avalanche photodiode is especially operated only in the high reverse bias conditions. This enables the avalanche multiplication of holes and electrons created by light impact. So as the photon enters the depletion region, it creates electron hole pairs. How? Due to transfer of energy from the photon to the ion, electrons excite from lower energy level to higher energy levels. With a sufficient energy, that electron will become free, creating holes over there. Hence, electron hole pair generation can be happened. These charge carriers will be pulled by the very high electric field away from one another. Due to reverse biasing conditions, the produced electron hole pairs will get attracted towards the terminals of the battery. Hence, their velocity goes on increasing to such an extent that when they collide with the lattice, they will create furthermore electron hole pairs, and the process will be repeated. In the figure, you can observe that the free electrons hits the atoms at high speed, hence producing a few new electron hole pairs, by which these new electron hole pairs again they will go for a repeated collision with the lattices and again producing more and more carriers over there. Coming to the characteristics of avalanche photodiode, as this can be operated in reverse biasing conditions. So the breakdown voltage depends on the density of doping, and rising of the density of the doping will reduce the breakdown voltage of the diode. And you can observe that the reverse characteristics of a avalanche photodiode, where when you are applying very high voltages also, there will be a minimum current in the circuit due to minority charge carriers, hence which is called as reverse saturation current. But when the breakdown voltage occurs, there will be a rise in current, where the diode can be operated safely with a very high currents due to multiplication of carriers by the collision of produced electron hole pairs with the lattice. Coming to the advantages and disadvantages, the main advantage of avalanche photodiode is the its high level sensitivity. As a result of avalanche gain is the advantage of this diode. Whereas coming to the disadvantages, much higher operating voltages may be required. Avalanche photodiode produces much higher level of noise than a PN photodiode. Avalanche process means that the output is not linear. And coming to the applications, typical applications of avalanche photodiodes are they can be used for range finders, long range fiber optic communication, quantum sensing for control algorithms. New applications include positron emission tomography and particle physics, and these are also becoming very crucial, available. Also lighting detection and optical SETI may be future applications, as it has become more prominent in today's life. Thank you.